All right, let's start from the top. All right, so there's three things I'm going to ask you in this set of questions. The first one's the amplitude, is always the A value, is 4. And this is for sine or cosine, okay?
What about tangent?
We'll talk about tangent and cotangent soon.
But sine and cosine are almost the same thing.
Pretty much, in this section. And basically, yeah. All right, so this one's the period. So the period's over here. Now you got to remember what the normal period for a sine wave is. 2 pi. So you got 2 pi divided by what your b value is over here, which is 5. So in this case, it's 2/5 pi, which means your period is 2/5 pi. Your vertical shift is -2. That means your vertical shift is -2. 3
But
points.
it's not like H where it like switches, it just always whatever it is.
The switching that's occurring is that because you divide by 5 in here
Can you
versus
show us
multiply
what that
by
would
5.
actually like be on because I feel like this not like I feel like you're gonna give us a really hard one where we're gonna actually have to do work.
I mean, it can't be much harder, man. It's just like,
It's just gonna be like this.
I mean, what can I do? There's only 3 things I'm asking for. There's only 3 ways you get it.
Okay. Or you have to graph this.
There's the first section is just putting it in. The second version is
If
graphing.
it was the other test, would it be with domain and range? We'd have to also find
What do you mean the other test?
like the video.
My
that we
older,
did.
yeah, the other one said domain and range, but you don't have to do domain and range.
Okay.
All right, another one. Let's do tan or cotangent. Let's do 2 tan 1/4 pi or 1/4x minus 1. In this one, you're still looking for the amp, the period, and the vertical shift. Okay. So the amplitude here, remember, tan and cotangent has no amplitude. Doesn't make sense because it goes on forever. So you never describe an amplitude. You could write the null symbol or no amplitude. The period is still divided by 1/4.
What's the amplitude?
Nothing. There's no amplitude for it. No, not 0. Null or no to amplitude, no
Why do I have
amp.
no answer?
No amp. That's fine. Something like that, okay? All right. The period,
Is it still 2 pi?
no. For tan, it's going to be instead pi. So pi over 1/4, which is the same thing as 4 pi. So the period is 4 pi.
You know when you're thinking about someone and then they randomly end up texting you like,
or when you're talking about someone and then they like text you.
Maybe. I don't know. All right. And then vertical shift is just a number here, which is -1. Okay. Just remember, tan, no amplitude, or cotangent, I should say.
How many questions are there?
There's 2 of these. One sine, cosine, one tangent, cotangent
That's it?
for that. And then we're going to do 2 graphing, 1 tan, sine, or 1 sine, cosine, 1
So like 10
tan.
questions?
And then a couple, yeah. So like 9, actually. Okay.
Are we gonna graph it or?
So now we're in the section where we're graphing. And I'll show you the way I would just suggest you graph.
If it was secant, does it matter? Would it be changed in sign or the same thing?
Secant is a whole different thing. Secant and cosecant.
No, for the equation you gave us before, like the 4 sine and 5x minus 2. If it was like 4 secant 5x minus 2, would it be the same thing?
Actually, for sine and cosine, technically would be. Yeah, the domain is very particular about that, but again, you're not going to do. I'm telling you straight up, you're not getting secant, cosecant. Okay.
Okay.
In this section. All right. So let's sine, cosine. Let's do pi x minus 1. You get this blank thing right here, okay? All right. So then, on the test, it will say also find the amplitude, the period, and the vertical shift.
where are the markers for the board? I need to ask you a question that can't be put in the video.
And just wait until I finish the video.
Yeah.
All right, so the amplitude is still 2. The period is, remember, it's 2 pi divided by what's on the inside, in this case pi. We don't have to deal with any horizontal shifts on this test, so just 2. And the vertical shift is down 1. Okay? All right, so for this, we're going to put -1 as our vertical shift. Since our amplitude is 2, I know it's going to go up 2 and down 2. So I'm going to need what other 2 points on this y-axis?
Up to 1,
And down to?
-3.
Good.
Yeah, for y.
So what do you need to do? -1?
You put -1 first because that's your vertical shift. You're going down 1.
Mm-hmm.
Then you're going to go up 2 and then down 2, okay?
Why?
Because that's going to help you graph your amplitude.
But why? That's your the amplitude is always up 2 and down 2. That's what
It's amp the whatever the number is. So it's 2 in this case.
so
So
if it's 5, it'd be
Up 5,
-1
down
to
5.
4 and negative whatever.
yeah. So it'll be 4 to -6.
Oh.
All right. So cosine, I always suggest it. You draw one in the middle and one to the end. We're going to draw, it's going to say in the instructions to draw 2 periods. So I'm going to cut this in half and cut it in half again. So I'm going to have 8 tick marks in total, okay?
Why?
You'll see why.
If we have eight.
You need 2 periods, so this is the best way to graph it. Yeah. So we know what the period is. What's the period is? 2. And the second period, that'll be double or 4, right? And then we just fill in the gaps. This would be half of 2, which is 1. This would be half.
2 and we're at before.
2's, if I were to do it in order.
Midpoint.
Yeah, the midpoint.
Why does it go 2 times?
I'm going to ask on the test for 2 periods, so you have to give me 2 periods.
Oh,
So
you
here's
never-
2, here's
So
4,
just always take the amp
and double it, yeah.
You're always gonna ask for two periods. And
On the
it's
test,
times
yes.
2, whatever you get.
Yeah, it's whatever.
Okay.
It's times 2 the period, not the amp, I'm sorry.
Yeah.
They happen to be the same in this case. man.
Okay, yeah, okay.
Um,
So where?
So 2, 4, I cut it in half, 1 and 3, and I cut it in half one more time. Wait a second.
what did it equal?
I cut it in half one more time, so I'm going to get quarters effectively. So this one, this one.
Abby's like sick or whatever. She's doing it.
Okay. So 1 half. Oh, she gets better. 3 halves.
Say what you wish, so I know.
5 halves. Me too, yeah. 7 halves. You could put 3.5 if you want or whatever. I don't care. All right. Now cosine
2.5.
You just add a half.
2.5.
Oh.
3.54. Like
We like
Yeah.
right 2.5.
yeah, you can. Yeah. I'm so used to doing it with pi, so that's why I
3
use
over 2 is 1.5.
1.5.
Um,
Remember, you're just cutting in half. All right, so cosine are values. Do they start at 1 or 0 at the unit circle?
1.
1. So we're going to start at the top in this case, which is 1. And then we're going to go to the middle, to the bottom,
yeah.
to the middle, to the top. That'd be 1 cycle, or 1 period. To the middle, to the bottom, to the middle, to the top. That's 2 periods. Then, kindergarten skills, connect some dots. Cosine, I know, starts like this, while sine starts in the middle. So, because of that, I start cosine on the top of my amplitude, in this case over here, at 1.
But why would you put the points there? You just know you
Oh.
one middle, one bottom, one middle, one top, one middle.
The way we cut it up in pieces like this is how I set it up. It's purposely set up like that because I know since 2 will be a full circle, this will be halfway through and this will be a quarter way through, which means it keeps that pattern. If you do it the way I'm telling you right now, you can't get it wrong. But each...
Like, every time you graph it, it's one top at 1, one bottom, one lower, one middle, one top, one...
If it's
middle.
cosine, yes.
But it won't touch the center of the line. The sine will touch the center or no?
Sine and cosine touches the center. All of
No,
them.
like we'll have a dot on the 0 axis.
I don't need it unless it was one of the points that like
You
it
have
landed
a
on.
phone box for these kids?
That's for the other class, yeah.
Why not us?
Yeah, I don't care. So then over here, sine wave would start at 0. If this was a sine one, it'll be middle, top, middle, bottom, middle, top, middle, bottom, middle. So it'll be a sine wave would be like this, which is very similar. It's just
How do you know that though?
you need to know either you could either think of it as you know the beginning of your unit circle is either 0 or 1. And I know the unit circle, hopefully you know the unit circle, is 1 comma 0. Cosine is 1. And sine is the y value or 0. And then I just make my way.
Can my
from there.
calculator graph this for me?
You're not having a calculator that could graph / have trig functions. You will have to graph tangent. I'll tell you how to do it.
Wait, so why is it a -3 on the bottom and 1 on top?
So -1 is the middle line, or my vertical shift. So the middle is like here, okay? And then my amplitude is how much far I'm going from the middle. So I went up 2, that got me to 1, and I went down 2, which got me to -3.
And -1 is your middle because of the vertical shift.
Vertical shift, yes.
But basically, it should always just look.
Usually our middle's 0, but we got shifted
It should
down.
always
So
just
our
look
middle-
like a U.
It should look like a wave like this.
You know when you do this to dogs?
What shrinks it this way?
What shrinks it this way?
When they run,
That would be.
you realize that.
So how I told you to graph it, you make the tick marks match the numbers. Because if this is, let's say bigger, let's say it was like 5 pi, let's say, then my period's not 2, it's like 2 or 5th pi. So that would be shorter or increase the frequency. No. The way I'm telling you how to graph it is the way you do it, which means your x values are the one. What are you doing? Sit down. What are you kidding?
Kind of. Play your left shoe. Oops.
You gotta have that. Okay?
That's Alex. No, give it back to him. I won't touch it.
Give it to him and then appear.
That's.
No, sit
Hey,
down.
you're holding up the video right now.
All right.
In your wall.
All right. No one even said anything. Appreciate it. All right. Next one. Let's do tan. I don't need tan to be that long, to be fair. Tan or cotan. I'll show you both. But let's say 2 tan 1/3 x plus 1. So we got the amplitude, we have the vertical shift, and we have the period. So the amplitude does not matter in tan, so that doesn't exist. The period here is pi divided by 1/3, which ends up being 3 pi. And then the vertical shift is up 1.
You're done. Someone say Chandler.
Did you guys see Miss Romano?
What?
She was here.
She was here.
Yeah.
All right.
Kid, her child.
Her
Is she
child
the
is
teacher
a
next year?
boy.
So for this one,
Chandler, we need it.
Pedophile be gone.
Yo, we have a video where.
On the video?
that's not nice.
What are you eating?
So
Organic health cranberry.
Yeah, exactly what I just said.
this is 3 pi,
Doesn't have
It's on
and
the
this
video.
is 6 pi. Then we cut it in half. For tangent, you don't have to cut it into quarters. You could just cut it in half.
That kid's never gonna make a mistake. Like people
3/2 pi.
Wait, is
People still ask my mom. People card my mother.
wait,
Five
is there
over
ever an
5 over
amplitude
2
for
pi.
10?
5 over.
Is there
No.
ever an amplitude for 10?
What's up?
Is there ever an amplitude for 10?
Or cotan? No.
Oh, her.
Does your mother get carded? No.
Not 7 pi. Technically
Wait,
not.
how do I know what's in between 3 pi and 0?
If you never know, you could always just add them together and divide by 2.
You cut it half again?
You cut it half, but you don't have to cut it in half into quarters like the other one.
Oh, so you'll say find one.
No, it's still 2 periods, but for tan and cotan, cutting it in half again is like useless. I'll show you why. Okay.
No, I'm fine. I'm
So,
not dying.
the asymptotes for the tangent wave, because we don't have any horizontal shifts, will always be in your first and your third tick mark. Okay. So for tangent, you start at the midline, or the vertical shift, in this case 1, and you go up along the asymptote. You go through the asymptote. At the next tick mark, you should be at the midline again, or the vertical shift. Up. And then, let me refresh that one. Technically it goes on forever, but whatever.
You have to be like artistic
No, absolutely not. This is like a horrible curve. The curve should be more like
Along
this. But I'm looking at, when I look at it for this, I look at the asymptotes, I look at the dots, and I look at the direction.
How would I get through? I want to know how to get 3 pi over 2. How would I?
Oh, if you're unsure what's in between, just do 3 pi plus whatever you're getting in between. In this case, 0. Add them and divide by 2, which is 3 pi over 2.
Oh. So you start with only 2? You start with only 3 pi and 6 pi?
Yes. So the first thing I do is 3 pi and 6 pi. Then I cut it in half.
So how do you get 7 pi over 2?
That's 9 pi.
Not 9 pi over 2.
So 3 plus 6 is 9 pi
9 over 2.
divided by 2.
Okay.
Why is there less spots for this one than those spots?
Because for tangent, the key points, so sine, it goes 0, 1, 0, negative 1, 0, 1, 0, negative 1 for sine and cosine. For tangent, it just goes from, it never hits 0, right? So the only coordinate points that's consistent is 1, or I should say, yeah, like it'll go from 0 to undefined, to 0 to undefined, to 0 to undefined.
So can we do that?
You could cut it more, but it's worthless, I would say.
Okay.
It's absolutely worthless. So.
Wait, only for sine you start at 0?
Sine, you would start at the y-axis of 0, or whatever your midline is in this case, okay? So in this case, I go to 1. Yeah. If it's cotangent, if it was the same thing just in cotangent, thankfully it's pretty easy. The only difference is you just go downwards, okay? But it's the same process,
Just backward.
just upside down would be, I guess, more accurate.
How would you...
Are you gonna give us a cotangent?
That could?
How would you get both the...
Asymptotes?
2 periods? How would you do that?
Oh, okay.
What would you say?
You have 1 period, you multiply by 2.
So I'll just use it here so I don't keep erasing that thing. So I figured out the period's 3 pi. So you're given this like plus sign on the test. So you got to put 2 tick marks. The first one is 3 pi, and then I'm just doubling it, 6 pi. Then, second step, I'm going to cut it in half and figure out what's in between these two. This is going to be 3 pi over 2, and it happens to be 9 pi over 2. If you want to put 4.5 pi, that's fine.
Wait, because you cut...
I'm finding what's in between 3 and 6.
You add 3 pi to 0 and divide it by whatever it is. So 2. Like you add 3 pi and 6 pi and divide it by 2, and that's how you have 9 pi over 2.
Or you could think, what's in between 3 and 6? What is in between 3 and 6?
3.
No. In between 3 and 6.
4.5.
4.5, which is 9 over 2.
Sounds like ass.
Go away.
Wait, how far? Yeah, no,
What's in the middle between 3 and 6? Think about it.
Oh.
4.5 is...
Yeah.
I thought you know.
I got you. The pi doesn't matter because
Can
it's
we go
only
over
pi.
to more questions?
Yeah.
So how many questions? So these are 4 questions that were...
These arrows are gonna get me.
I'm sorry. But that's 1 point of the 5 points it is worth. Okay. Next one. Evaluating inverse trig.
Oh, no.
So for example, if I have arc sine of a half, make sure you know your unit circle or the triangles.
Also 30. No, so pi over 6.
So in this case, this would be what causes sine to be a half. That would be the 30-degree angle. But remember, I want it in radians because I'm actually asking for a value. So pi over 6. Either you know it as pi over 6 or you know it as 30 and then convert it.
If you draw if you draw this, not the unit circle, if you draw the 30, 60, 90 triangle?
I could draw it for you right now, but I won't draw it for you on the test.
No, yeah, for sure.
Yeah, okay. So here and here, for the 45, 45, remember in a unit circle, the hypotenuse is automatically 1. So it's root 2 over 2, root 2 over 2. And then your hypotenuse is 1 in this one for a 30, 60. For 30, it'll be a half. For 60 is root 3 over 2.
And how do I know when it's... So sine is always a half? Is always 30?
Well, let's see. I want the answer to be a half if
Yeah.
I put sine blank. I don't know what the angle is. So I need opposite over hypotenuse to be a half. So I look at the 30, 60. Which one will have the opposite over hypotenuse be a half? 30 degrees or 60 degrees?
30.
30. And then you could convert that into radians, which is pi over 6. The answer do have to be in radians because I'm asking you to evaluate it. not just give me the angle.
Radian to degrees pi over 180.
It's only the quadrants 1 and 4, right?
For sine, good question. For sine and for cosine, I'm sorry, for sine and tangent is quadrants 1 to 4.
To get degrees, to get from degrees.
Not
to radians.
cotangent, sine,
Pi
tangent,
180
tangent.
over pi over 180.
Yeah.
That is from first and fourth quadrant, aka pi over 2 and negative pi over 2.
Why do we need to know that?
I'll tell you in this. I'll show you in the next question why it's so important. And over here, if I want cosine, that means it's from 0 to 90 degrees, or 0 to 180. So, or 0 to pi.
So 1 and 2.
So 1 and 2 in that case, yeah.
Will it ever be 3?
No, not for the arc stuff.
So I don't get this. What did you do?
So let me explain why it is, okay? Let's do another one. Arc cosine of negative root 2 over 2.
So 45.
It's not 45 degrees. It's negative root 2 over 2.
So
So the question is, like, where does it belong? Quadrant 1, quadrant 2, quadrant 3. For cosine, it's 0 to pi, so it has to be in the second quadrant. So it's going to be the 45 degree. Yeah, but it's going to be in the second quadrant.
1/3, 145.
135,
What? Oh,
Because 180.
which is going to be 3 pi over 4. Yeah, 3 pi over 4.
why?
Why is it negative? Isn't it 135?
135 would be degrees. 135 degrees. If you put cosine 135, you will get negative root 2 over 2. In the unit circle, that makes sense.
Don't you want the negative answer since it's...
No, I'm asking, when I ask for arc cosine, what I'm basically asking, cosine of what angle gives me negative root 2 over 2? In this case, there's technically infinite amount of angles that gives me because you can keep rotating. So they had to limit it to only 2 quadrants, first quadrant and second quadrant.
So once I give you that answer, that 3 pi over 4, that's it, I'm done?
Yeah, that's it.
That's all you want? You don't want that whole like weird split
Wait,
with
why
all
is
those like
cosine-
things on the side?
No,
All we need to know is all students teach calculus.
that helps you. Yeah.
Wait, why is cosine not also in the third quadrant?
Because what's cosine in this section? It's also what?
Negative.
No, that's the problem. It's not negative. It's positive.
Positive.
So if I said, give me
Root
give
2
me
over 2,
cosine root 2 over 2.
Then you would do
You do 45 degrees or negative 45 degrees?
45 degrees.
Both answers are correct, and that's a problem. It has to be a function that only gives you one answer
Wait,
per
why would
input.
it be both?
So they have to limit it because negative 45 degrees will also give you root 2 over 2.
But negative root 2
For
over 2
cosine.
Isn't that... Can't you also get that in the third quadrant?
You could get it in a bunch of quadrants, yeah. So mathematicians agreed like cosine is going to be from 0 to pi, and sine and tangent is going to be from negative 2 pi to pi. That's just what they agreed on.
Negative 2 pi.
I'm sorry, negative pi over 2 to pi over 2.
So we need to remember that.
You need to know that because that
So
matters.
cosine will only go from 0 to 180,
Mm-hmm.
and then sine will go from 90 to what is pi over negative pi over 2.
Say that again.
Negative pi over 2 is what in degrees?
Negative pi over 2, 90 degrees.
So it goes from 90 degrees to negative 90 degrees, which would be technically
The first and fourth quadrant.
okay.
Okay. So let's say if you had something like this. Cosine, arc cosine
Oh boy.
of 3. Let's first look at this. Arc cosine of 3. Think about this. Cosine theta, can it ever give you an answer of 3 in the unit circle?
No.
Why not? I'm going to say you're correct, but why not? Because in the unit circle, it only can produce from a maximum of 1 to the minimum of negative 1.
Oh, it's tan and tan arc, whatever.
So in this case, arc cosine of 3 cannot happen. That is not a solution. So this is no solution, okay?
What else can there be no solution?
If I did it with sine. But tan, arc tan of 3, what's the range of tangent? The range of tangent goes from negative infinity to infinity, which means there is some angle that could get 3 in tangent. which means arctan and tan cancels each other out, which in your final answer here is 3.
What is 10 out of 10?
Because arctan is going to get you some degree, some angle, that causes you to get 3 in tangent. Wait a second. Tangent of 3, or tangent of that mystery angle, we already know it should be 3.
So if you give us this on the test,
So
basically
why
it's
should
not-
it be 3?
Arctan, or tan negative 1 of 3. That's the same thing as saying tan of what theta equals 3. Okay, so this is some theta, some mystery theta, which I can't figure out because it's not one of my perfect right triangles without a calculator. No, we don't know what it is. I don't know what it is, you don't know what it is.
So if it was like sine, arc sine 3, would also be no solution?
Say again?
Arc sine, cosine, arc sine 3. Like
Arc?
the exact same as cosine. Would it be crossed out, or would it just give you, it would be 3 just like tangent?
It would be just 3. The final
So
answer
sine
is
and
just
tangent can give you an answer, cosine gives you no answer.
no. Cosine could give you an answer.
So why didn't they give you an answer? They gave you no solution.
I'll tell you. Okay, wait a second. So let's first understand this. Arctan of 3 equals theta. That's the same thing as saying tan of theta equals 3, correct?
Yeah.
So I could write this as some mystery theta. We could put a little sub 3, a theta that causes 3 in tangent. So tan of theta will be 3. Wait a second. I know what tan of theta is. What is it? 3. So that's why my answer is 3 in this case.
And that's always going to be for tan?
Tan is good because it never cancels out.
So
The
whatever
range
the
is
number is gives you in there, if it's tan, arc, tan, just whatever the number is inside.
yeah, pretty much.
You can't put like you can't put pi in it.
You could put pi. Pi is a number between negative infinity and
No,
infinity.
but instead of 3.
I could have put pi.
So wait, well, how would you
Your answer would be pi, because pi is just some number. Remember, it's 3.14.
Wait, but
So how
There's
would-
something else you're thinking about. I'll get to that eventually.
What would cosine? Why did you get a no solution?
Okay, cosine. I'm saying here. This statement is saying here. I'll do it in red. This statement is saying here. Arc cosine of 3 equals theta. Okay, which I'm saying cosine, basically in other words, theta equals some theta equals 3. Now, we talked about a bit about the graphing. I don't have the base form. But don't you remember what's the range of a cosine wave? What's the range of a cosine wave? No, the range. It goes from the top to the bottom on a normal cosine wave. How high does it go? How low does it go?
1,
2.
negative 1.
Okay, is 3 within 1 and negative 1?
No.
So what's the problem? This is impossible. There is no theta that could cause a 3.
So it has to go through 1 and negative 1 for it to be something? So
For
if it was
sine and
0.5,
cosine.
it would be yes.
Yeah, so exactly. I wanted to follow up with that. So if I have
0.5 or
Yeah, yeah. if I had something like cosine, arc cosine of like 0.75, that case, there's some value that causes 0.75 for cosine. It's some mystery theta, but I'm putting that theta into cosine. So it's just going to be 0.75.
Same thing for sine, but sine would be 0.
It's still also negative 1 number. Sine
Oh,
is
yeah,
still-
it is. So sine is also negative 1.
yeah.
So for cosine, if it's in between 1 and negative 1, then
You're good.
that's just that number in there.
And if it's like exactly like the setup, yeah.
Okay, and so and it's same thing with tan.
This is the whole test. This is the
Tan always works though. There's no problem because the range for tan is negative infinity to infinity.
And sine's the same as cosine.
Sine is going
This
to
is
suck
the
up.
end of the test.
Well, I want to do more skews of that. That was like
Yeah.
okay, but that would be the last. This is the last section of the test for sure. All right, so we did it. Where's trig and inverse trig? Let's do a reverse. Arc cosine of cosine of let's do 7 pi over 4. All right. First off, you need to figure out what cosine 7 pi over 4 is.
Like the reference angle?
Yeah, that'll help you, but
So 7 pi. So you can do 7 pi over 4 times.
You could do it in degrees.
180 over 5.
If you do it in degrees, you'll find it's going to be 325 degrees. Okay? All right, 325. So cosine of 325 degrees.
So it's 45.
So as a reference angle of 45 degrees, so what is the answer here if it's in the fourth quadrant?
Also, the negative.
Not negative root 2 over 2. It's cosine, so it's going to be positive root 2 over 2. Okay, so now I have arc cosine of root 2 over 2. Arc cosine of root 2 over 2.
That would then be.
What causes root 2 over 2 in the arc cosine?
What causes it?
Yeah.
Negative 45.
Just 45 degrees, or pi over 4. So your final answer here is not 7 pi over 4, but pi over 4.
That's it?
I'll do some more.
No, I'm saying that that's the answer.
That's the answer for this, yeah.
This is some more.
Good. Another one. Okay. Sine tan. Oh, sorry. Sine arctan. My bad. Of 3 over 4.
Can we got this?
How are you gonna do
would
this?
3 over 4 would be translated to. We do 3 over 4 times pi over 180.
Okay.
Is there an easier way to do this though?
Yeah, you definitely don't want to do it this way. Because 3 over 4 is not any of my answers to tangent questions, right?
4, 5.
Oh.
So what we can do is we know it's some mystery theta. We don't know what it is. It's some mystery angle. So it's some mystery angle where the opposite, because it's tan, the opposite is 3, and the adjacent is 4, which means I can fill out this triangle. This is a 3, 4, 5 right triangle. Okay, if I know that, it's some mystery theta of this mystery triangle.
Cool. But we need a calculator.
No, you don't, because I don't need an actual theta. Because if I have sine of theta,
Sine 3 over
I can
5.
visualize it literally.
So
So
sine
it's,
3 over 5.
so it's just 3 over 5.
But you have to know that it's a 3, 4, 5 triangle.
Or use Pythagorean theorem, but.
But that's what we'd have to do if that's what it's like. If
So
it's
this
not
one,
6 over 3,
this occurs when your arc and sine, or whatever it is, the normal and the inverse, are different. Then you're probably making a right triangle of it.
What do you mean?
So like all these, like it was cosine, cosine, or cosine, arc,
Oh,
cosine.
if it's
Sine,
sine
arc,
and
sine.
tan or sine, cosine,
Yeah, yeah,
that's a
yeah.
right triangle.
And that one, I'm afraid I could freely do also like if it was secant or something like that.
You can do that.
I could do that.
Can't do it for these problems.
That's the tough part. I would agree with that. This one is unique because the two of them are different. Okay.
What if it was like tan root 3 over 3?
Root 3 over 3.
Because then you could find the arc tan.
You could. I mean, then it's root 3 over 3, which is, you could either put root 3 here and then figure out the thing.
It'd be 30, right?
In that case, it would be tan of root 3 over 3 is 30 degrees.
So pi over 6 and sine from pi over 6.
Yeah, sine of pi over 6, which is sine pi over 6, which is a small one, a half in that case. Okay. Okay. So if the first thing we did was normal with an inverse inside, that's when you could cancel out if possible. The second version is the inverse with the normal on the inside. That one you have to check and make sure you kind of translate it to the right. Basically, you're translating it to the right quadrant.
So if it's cosine and then arc cosine inside, you can cross them out.
If you remember the rule, though, if it's between 0 and 1, between -1 and 1. That's for.
If I remember the rule, then there's no way to keep the answer.
If you, well, you just put the wrong answer because you will just cross it out. Like this one, you could have said 3 in accident, but that would be wrong. And then the last one is when they're different. That's when you make a right triangle. Okay. So it's really only 3 versions, plus the general. What is the arc cosine? 3 versions of the one and the other. That is not on it. That's our